Hi everyone, thank you for watching this video. Now in this part of the lessons today, we are going to do a quick review on the angle properties of parallel lines and maybe also a little bit on adjacent angles on straight lines and angle sum of triangles. Now, we are going to use these properties to find different angles and at the same time probably use these properties to prove either that two lines are parallels or also can use it to prove other statements. So before we begin, let's take a look at some of the angle properties that we commonly use. Number one, first one, this one is on this one is on corresponding angles on parallel lines. So when you have two parallel lines, okay, and the angles over here, these two, they look like a letter F, they are corresponding to each other. This means that these two, angle A is equals to angle B. So this will be corresponding angles on parallel lines. Remember to indicate that they are on parallel lines. Okay, if it's not parallelized, then they are not equal to each other. Next one, we have also the interior angle on parallel lines. So if you have two parallel lines that looks like this, or maybe a letter C, okay, then what is so special about the interior angles? The two angles over here will add up to 180 degrees. So A plus B equals to 180 degrees. So these are called interior angles on parallel lines. Let me write the short form. Interior angles on parallel lines. Okay, and next one we have the alternate angles. So if you have two horizontal straight lines or two parallel lines itself, and they form there's a transverse going across these two lines and they form like a letter Z. Okay, these two angles are alternate angles. They will be equals to each other, and this is called alternate angles on parallel lines. So remember, you can have alternate angles, but if they are not parallel, they are not equal. Now these three properties here are quite useful. We can use these three properties to prove that two lines are parallel. So probably when you do proving and they want you to show that this is a parallelogram or this is a trapezium or these two lines are parallel to each other, you can use one of these three rules. Okay, the others that come in very handy and very used quite often will be for this one over here. Let's say I have two lines straight lines that cut each other, and this angle over here, they are called vertically and opposite angles. They will be equals to each other. Vertically opposite angles. So you need to write the vertical. Okay. Next, looking at this, some of the common ones we also have this one over here, where you have the angle A plus the angle B is equals to 180 degrees. This is called adjacent angles on a straight line. Alright, then the other common one, we have A plus B plus C angle sum of triangle to be equals to 180. So this is angle sum of triangle. Okay, one of the other properties that is quite useful and is a shortcut but less used by students in general is this property called the interior angles. The sum of the two interior opposite angles is equals to the exterior angle. Okay, equals to this exterior angle. So what does this mean? For example, right, if I have this one is 30 degrees and this one is maybe 45 degrees, okay, what do we have? Usually what students will do, they will go and find this angle over here, right? And then they will tell me that this is 180 minus 30 minus 45 to give me 105. Then after which they are going to use 180 minus 105 to equate this to get the angle 75 degrees. But from here you can actually notice the angle 75 degrees is actually equals to the exterior angle is actually equals to the sum of the two interior opposite angles. Okay, so this 75 is actually equals to 30 plus 45. So if you want, you can do actually a shortcut. Don't need to find the angle over here. You don't find this angle, and you can straight away find the exterior angle. So this is called exterior angles of triangle. Okay, the exterior angle is equals to the sum of the two interior opposite angles. So now this one is some of the common properties, okay, that we will be using. Right, let's move on to our question. Okay, first question. Now, inside this question here, we have A, B, and C, D are straight lines which crosses two parallel lines. So just let me indicate out where are the two parallel lines. So this line is the parallel line, and we have two straight lines A, B, and C, D. First one, they asked me to find angle A given a reason. So I need to state the reason. So angle A, if you look at this is like a letter F over here. Okay, so this angle is 48 degrees by corresponding angles on parallel lines. So A equals to 48 degrees because of corresponding angles on parallel lines. Now this is the approved short form that will be accepted during examination. So if you want to save time, you can write this property. Okay, next one, calculate angle B. What do they ask me to do? I need to calculate angle B. I can use the corresponding angles once again. This is 53, so this angle is also 53. Then I'm going to use adjacent angles on a straight line. So angle sum of angles on a straight lines to find the angle part B. So B will be equals to 180 minus 53 minus 48 adjacent angles on a straight line. Okay, and this answer will be 79 degrees. Right, next question. Okay, question number 2. Inside this diagram, PQ is parallel to RS. Let me just indicate the parallel line. So this is PQ. And this is RS. We have so many different angles. Show giving reasons that the angle C is 64. So I just need to find angle C. Correct? Okay, so what can I do with angle C? What are the angles that are actually equals to angle C? Angle C is equals to angle G, corresponding angles on parallel lines, and you can use to find angle G using the angle 116 adjacent angles on a straight line. Okay, they say show giving reasons, so I'm going to find angle G first, then I'm going to find angle C. So step 1 and step 2. So I need to write the reasons for both the steps. So first one, angle G is equals to 180 minus 116 degrees. And that's 64 degrees. Giving the reasons. So state the reasons. This is called adjacent angles on a straight line. Okay. Then after that, angles C equals to angle G, which is equals to 64 degrees. This is because of corresponding, letter F, right? Corresponding angles on parallel lines. Right? Have you gotten the answer? Now let's move on to the next question. Okay, next question. Question number 3. So now in this case, you can see that in this diagram there is a set of parallel lines. So let me highlight the parallel lines first. I have these parallel lines. Okay, and the question asked me to find angle A. Angle A is over here, right? So what do we notice? How to find angle A? I have the exterior angle of the triangle 1, 2, 4. The exterior angle of the triangle is equals to the sum of the interior opposite angles. So that means 82 plus A will give you the angle 124. So now in order to find A will be equals to 124 subtract 82. Okay, 124 subtract 80 will give you 42 degrees because of exterior angle of triangle. Now, some of you may also write a longer method. If you do by the longer method, they will give you will need to do angle sum of triangles for this reason, and then you do 180 minus adjacent angles on a straight line. But that is technically not very accurate because the question actually says calculate A and give a reason. So they technically only want one particular reason to summarize your actions. So the actions that you're actually trying to show is the property on exterior angle of triangle. Okay, and for the next question, we want angle B over here. Angle B, in this case, we can see that this is a pair of alternate angles on parallel line. There's a letter Z down here. So this one, angle B, is just simply 82 degrees by alternate angles on parallel lines. Okay. So we'll go on to the next question. Up next, in the next few questions, we are going to look at how we can use angle properties to explain or to prove or to show certain properties. For example, parallel lines, isosceles triangle, trapezium, parallelogram, so on and so forth. So let's take a look at the questions. Question number 4. In the diagram, angle BAC is equals to 90 degrees. So we have this one over here, 90 degrees. Okay, and angle ABC is equals to 40. BD is a straight line, and you notice that the question AD is equals to BD. So if I have AD to be equals to BD, this is an isosceles triangle. Always indicate more information on your diagram to help you. So now I know that this is definitely going to be 40 degrees because it's base angles of isosceles triangle. Base angles of isosceles triangle are equal to each other. Now, since I know that this is 40, the angle over here is 90 degrees. That means we'll know straight away that this angle is 50 degrees. Okay, let's take a look at a question that they want me to do. First one, part A, find angle BAD. Well, angle BAD is equals to 40 degrees. Reason being, base angles of isosceles triangle. Okay, they are equal to each other. Next one, calculate angle ADC. To calculate angle ADC, again, I can use my exterior angle of triangle. So the exterior angle of the triangle is equals to the sum of the two interior opposite angles. So I'll just take 40 plus 40, that means this angle is going to be 80 degrees. So angle ADC is 40 plus 40, which is 80 degrees, exterior angle of triangle. Right? Now, next part of the question says, using your answers to part A, explain why triangle ADC is isosceles. Well, if I want to prove that this angle is isosceles, either there are two properties. Number one, either that they have two sides with equal length. Okay, or you can have two angles that are equal. two equal angles. Okay, but in this case, I do not know the length, so I shall go for the angles. And the only angle in down here that's unknown will be angle C. But of course, I need to explain to them what I found for angle DAC. So I'm going to write down the working. Angle DAC is equals to 90 degrees minus 40 and give me 50 degrees. This is what I found. And now I want to find angle ACD. That will be 180 subtract 50 subtract 80 by angle sum of triangles. Okay, so this will be 180 minus 50 minus 80 to give me 50 degrees. We have two of them with the same angle. Then we need to explain, since angle DAC equals to angle ACD, so we have two equal angles, therefore triangle DAC is isosceles. Okay, have you gotten the concept? Now we shall move on to the other types of questions. Question number 5. Now take a look at this diagram over here. EFGH is a quadrilateral with the statement EH is equals to HG. So E to H is equals to H to G. So we have an isosceles triangle. Okay, and angle EFG is 90 degrees. So this is 90 degrees. Okay, HG is angle X. Okay, given that angle EHG is twice angle EGF. Where is angle EHG? Oh, angle EHG is X. So this one over here, this angle is twice, meaning that this is 2 units. Okay, that of angle EGF. EGF is this angle over here. Okay, so what will we have for this angle? If this X is 2 units, this one will be X divided by 2. So it's half of angle X. Okay, so these are some information that we know. And on top of that, we also know some other information, right? They asked me to explain why EFGH is a trapezium. What does a trapezium, what are the properties of a trapezium? A trapezium has one pair of parallel sides. So in this case, right, what are the angle properties that I can use to prove parallel lines? So angle properties that have parallel lines are involving corresponding angles on parallel lines, interior angles on parallel lines, okay, or alternate angles on parallel lines. So there are so many angles over here that we can actually use. But first, let's try to find more information. So far, I only have angle EGF to be half X. Well, but I know that this angle, these two sides here are isosceles. This angle EH is equals to HG is an isosceles triangle. That means this angle over here can be found, right? So I'm going to find that angle first. Angle HEG is equals to 180 minus X divided by 2. This is angle sum of triangles, right? Okay, and leaving the, you can see that this one looks a little bit complicated, and this version here we have this in simplified form, half X. So what we're going to do, we're going to divide each of the numbers over here individually. So 180 divided by 2, that will give me 90. X divided by 2, that will give me half X. Okay, so that's what I will get. So I'll write this down. This is 90 degrees minus half X, and isosceles angle, triangle, right? So angle HGE is also 90 degrees minus half X, base angles of isosceles triangle. So this is 90 degrees minus half x. So if that's the case, what other angles can I find? Okay, this one is the only remaining angle that we haven't found so far. We have this angle over here. So maybe you can try to use this angle. Or we can also use interior angles on parallel lines. We can just find the sum of this angle as well. Okay, for me in this case, I'm going to use interior angles of parallel lines so that I have one less angle to calculate, right? So in this case, if I know that this is 90 minus half x, this is half x, so that means angle FGH, the whole angle over here, this whole angle, okay, will be given by 90 degrees minus half x plus another half x. And this happens to simplify to just the angle 90 degrees. Now we notice that the angle over here, EFG, is also 90 degrees. And the two angles now add up to 180 degrees. Okay, so what does that mean? That means since angle EFG plus angle HGF is equals to 180 degrees by interior angles. In this case, please write the full property names because you're going to explain why it's a trapezium. By interior angles on parallel lines, right? What can we conclude? Can we say that it's a trapezium directly? No, we are going to conclude about the lines first. EF and HG are parallel to each other. Is parallel to HG. Since there's one pair of parallel sides, therefore EFGH is a trapezium. Sure. Have you gotten the concept? Now, of course, we can write the other versions. We can also use find this angle over here, okay, the blue color angle, and then equate it to the angle over here to get alternate angles on parallel lines. Okay, but that need a little bit more calculation, so I have chosen interior angles on parallel lines. Alright, I'll move on to the next question. Okay, the last question for today. In this figure over here, we have A, B, C, D, E to be a pentagon. Now, what do you mean by a pentagon? A pentagon itself has how many sides? Now, we know that pentagon has 5 sides. N is equals to 5. The angle sum of a pentagon is n minus 2 times 180. So in this case, we will have 5 minus 2 times 180. That's 3 times 180 to give me 540 degrees. Okay, so this is some information that we have. Next one, we have AE is parallel to CD. AE is parallel to CD. Now take note, they did not tell me ED is parallel to AC. So please do not anyhow use your alternate angles or interior angles. Okay, next one, they say AB is equals to BC. So we have a pair of isosceles triangle. If I have a pair of isosceles triangle, I can find the angle over here. Okay, this angle will now be 180 minus 144 divided by 2. Base angles of isosceles triangle. Now this is just one of my habits. I like to write down information or angles that I can actually find on my diagram, and I can try to use them later. Okay, now let's take a look at the angles. They gave me 144, right? Then 120, AED is 78. Now they want me to find angle EDC. angle EDC over here. Now we notice that these two lines are parallel to each other, so we can have interior angles on parallel lines. So therefore this angle 78 plus angle EDC will give you 180 degrees. That means angle EDC is given by 180 subtract 78 degrees because of, that's 102, because of interior angles on parallel lines. Okay, so this one is the angle 102 degrees. Next one, find the angle BCD. BCD is the angle over here. BCD, the whole of the angle BCD. So now I know that this is actually a pentagon. I have 78, 102, 120, 144. So I can use angle sum of pentagon to find this angle over here. So this one will be, we found the angle of pentagon to be 540 already. So that will be 540 subtract 78, 102, 120, 144. Okay, to give me an angle of 96 degrees. Alright, and this reason is because of angle sum of pentagon. Okay, instead of angle sum of triangle, it's angle sum of pentagon. Alright, so now next part of the question, explain why the quadrilateral ACDE is a parallelogram. Now, what are the properties of a parallelogram? A parallelogram has two pairs of parallel lines, parallel sides, right? Two pairs. So let's take a look at ABCDE. ABCDE over here, we already have one pair of parallel lines, which is AE is parallel to DC. That means I need to prove and show that the next pair of parallel line, ED, is going to be parallel to AC. I need to show it. So either I can show by, in this case, I don't have corresponding angles, and that hardly any alternate angles, so most likely we are going to show interior angles on parallel lines. So if this is the parallel lines, let's look at interior angles. The interior angle will be here, 78, and I probably need to find this small portion over here. Okay, this small portion over here until the cutoff point. Okay, maybe I need to draw a bit more. Okay, the whole angle is 120, but I only want this part of the angle, right? We already know that this angle is 18, so this part of the angle will be 120 minus 18. But first, let us explain to them what we have done. How did we find angle BAC? Alright, so we should write down angle BAC first. So number one, we're going to write down angle BAC first. Angle BAC is equals to 180 minus 144 over 2. And that gives me 18 degrees. Base angles of isosceles triangle, or angle sum of isosceles triangle. Then now I know that this is true. Then we shall find angle EAC over here. Okay, so angle EAC. So the next one we will have angle EAC to be 120 subtract 18. Let's see what does we get. I'll get 102 degrees. Alright. And then now I'm going to look at, if this is 102, I need to check is 78 plus 102, sorry. Is 78 degrees plus 102 degrees equals to 180? Yes, it is. So therefore, we're going to have interior angles on parallel lines. Right? So now we have this one over here. Since angle, what's the angle name again? EAED, angle EAD, plus angle EAC equals to 1 is 78 degrees plus 102 degrees is equals to 180 degrees by interior angles. Now in this case we need to explain, so we'll need to write the full property name. Angles on parallel lines. I conclude that the line ED is parallel to AC. So I'm going to conclude that ED is parallel to AC. Since this is a pair of parallel lines and the other pair of parallel lines is given to us, therefore ACDE is a parallelogram. Okay, two pairs of parallel lines. Okay, have you gotten the answer? We have come to the end of our lesson. I'll see you again for the next lesson.